Some other issues that come with sampling, and we're going to define some of the sampling methods that we talked about or we did yesterday, experienced yesterday, kind of formalize those today. So we didn't get to this part. What is beneficial? When is it beneficial to use a stratified random sample? The benefit is it's a more precise estimate. It's a more precise estimate. Okay? This is very, very, very important to understand the difference between precision and accuracy. Are those two things the same thing? No. Precision is all of my estimates are very close together. Doesn't necessarily mean that they're close to the actual value, but they're close together. Accuracy is that my estimates are centered around the actual value. Okay, that's accuracy. All right, so those are the two different things. So when is it beneficial? When there's a variable that affects the outcome that we're looking to observe. So we talked about the height example on Friday about students in the high school and their average height. It's beneficial to stratify, right? It's beneficial to stratify probably by gender and by grade. That would probably be the best. Could we do both? Yeah, we could. I could get, if I was looking for a sample of 40, I could get 5 male freshmen, 5 female freshmen, 5 male sophomores, 5 female sophomores. That's going to give me the most precise estimate. Would an SRS be bad? No, but it wouldn't be the best method to do. Okay? So, how do you choose a variable to stratify by? We're going to pick the variable that is the best predictor of what we're trying to measure, the variable that has the strongest association. Okay? Variable has the strongest association. A lot of times it might be gender. If we're doing the high school, it might be grade, or it might be age. Something along those lines is normally what we're going to be stratifying by. Okay? Does that kind of make sense? Any questions about stratified random sample? So, what is a cluster sample?
When you split it up into like separate groups and then you just take that whole cluster.
There you go. So cluster sample is I am splitting up my things into separate groups and doing an SRS of the groups and then sampling everybody in that group. So if you think about it, yesterday we did the rows. The rows were my groups. I got one number, 1 through 10, and then I sampled every plot that was in that row. Right? That would be a cluster sample. There's a lot here. Okay? The sampling technique where you classify the population into groups that are located near each other, called clusters. So this is different than strata. Okay? Strata is we're picking a variable that's associated to what we're looking for. Clusters, we're picking something that's based off of location. Okay? And we're going to do an SRS of those clusters and all the individuals that are in that cluster are included in the sample. Okay? So why do we use a cluster sample? Why would it be beneficial for us to use a cluster sample? Somebody give me a scenario that you think would be beneficial.
Which region of the country produces the most crops?
Okay. So the clusters might be the different regions, and I sample.
Southeast, the states in the southeast.
Okay. So the problem is with that is that if I just get the southeast, I'm sampling everywhere in the southeast. I'm only getting the southeasts.
No, but then compare that to the northeast.
But then I would have to do like basically all of them. A stratified might be better in that scenario. Okay. Cluster, yeah. Go ahead.
Like if you're talking about counties in the state,
Okay.
and let's say what he said, like with crops, you could do each county and then you pick
Okay.
just say Georgia, like one state.
Okay, so this scenario might be better. Like if I was trying to find, the state has a new legislation about gun control. Let's say that. Okay, hot topic right now. The state is looking to legislate gun control a little bit differently, and they're trying to get the entire state's kind of reaction to that. A way that we can do that by county in the state of Georgia is all the counties can be a cluster, and I can maybe get 5 counties. And then every individual that's in that county, I'm going to find their opinion on this new bill. Rather than trying to do an SRS and number everybody in the state of Georgia, that might be a difficult thing. Okay. Stratifying might also be a difficult thing because if I'm looking at the counties, I'm going to have to do an SRS within each county. That's pretty tough. So a cluster sample might be the best option here because the location. And I can go to that county's government and say, look, you have to administer this poll or this vote or whatever, and we want to see the opinion of the people in your county. That might give us a snapshot of the state of Georgia. Okay, so that's why a cluster would be beneficial there when location is an issue. Does that kind of make sense? The difference between that and the cropping. So how is that different than stratified? Because it is. What's stratified? What's that? Well, stratified is a little bit more precise. Let's not talk about kind of the results of it, but yes, it is more precise.
Stratified is when you would take samples inside the groups.
So I'm going to take an individual SRS within each group, right? A cluster is I'm taking an SRS of the groups and sampling everybody in the groups that I select. Okay, there's a little bit of a difference there. Okay, what are the drawbacks to a cluster? Yeah. In the county example, I might get all the regions that are right around Atlanta, and they might have a different opinion on gun control than some of the more rural areas of Georgia, right? There's a possibility that's an issue. It might not be a great representation of your population. We use a cluster more for the fact that it's easy rather than for it's more precise. Now, the cluster sample for our thing was really precise, the river one, but not necessarily for some other issues. Okay, does that make sense? Cool. So, like, if we took let's say we did a cluster sample for all like K2 through 12th grade, and I'm trying to figure that their opinions on dress code, right? And I'm gonna get 3 different grades and just sample everybody in there, right? And let's say I get K2, K3, K4. Well, my daughter's in K2. She loves her uniform. Like, loves it. Like, is excited to wear it every day, right? But if I got 10th, 11th, 12th, that opinion might be a little bit different, right, on the uniform, right? So there's a little bit of a drawback there. Okay, you're not getting an equal representation of the entire population, right? Sweet. All right. That was a lot about clustering. So let's move on. Where am I? Okay. So I have this example. Okay, and I have a lot of stuff written here. This is all online. What I want you guys to do is kind of go through together with the people that are near you and talk about this and write down your answers. If you want to go back and fill in with my answers later, you can. We're going to go over each one together. But I want you guys to discuss and talk about kind of where you are with your example and what you think. So let's talk about this. The school librarian wants to know the average number of pages in all the books in the library. The library has 20,000 books arranged by type: fiction, biography, history, so on. So all these different types. In shelves that hold about 50 books each. So we're going to talk about each scenario: simple random sample, stratified random sample, and a cluster sample. There's 20,000 books. We're getting a sample of 500 books in each scenario. So kind of just talk about how you would obtain SRS, stratified, and cluster for this scenario. With your group, maybe kind of jot down kind of key bullet points. And then at the end, talk about some potential drawbacks. And then we'll reconvene and come together and talk about kind of big picture. We'll talk about everybody's examples, all right? So go.